Hello, my name is John Scotto, and I'll be going over the SBM Trailers Model Coal Train. This is for the Engineering Advisory Board. This is the preliminary final presentation. The following contents we're going to be going over is the introduction, purpose and identity of project, project constraints, project associated risks, schedule and timeline, budget and funding, considerations for senior design, the second step. The following team members are John Scotto, myself, Cole Tinsley, Taylor B., and Ethan Myers. We are all mechanical engineers getting ready to graduate this upcoming May at St. Martin's University. Myself, I'm in charge of the investor relations. I'm an experienced farmer. I own three separate businesses, all different LLCs within the agricultural industry. So by me being able to take what I've learned in the personal business and in these industries, I was able to get into contact with various different businesses and business owners in order to provide us some funding for this build and this project. Cole Tinsley, he's the lead researcher. Cole focused on researching the legal and ethical codes, ensuring the trailer adhered to regulatory codes and other relevant standards. His work ensured that the design was not only functional, but also legally compliant and sustainable. Taylor B., team manager. Taylor B. manages the project, coordinated tasks, set deadlines, and ensures the team members stayed on track using tools like Gantt charts to monitor progress. His leadership kept the project organized and moving forward. Ethan Myers, lead CAD designer. Ethan Myers led the technical aspects, developing CAD models, performing load-bearing calculations, ensuring the design complied with industry standards. His role was crucial in translating the concept into functional, manufacturable trailer designs. Project identity and purpose. The project aims to build the foundation for developing a hay trailer that is road legal and compatible with a 53-foot NHTSA approved semi-truck trailer. Primary objectives include creating a self-loading and unloading trailer to eliminate the need for seasonal labor, improve operational efficiency, and reduce workplace risks associated with manual hay handling. Initial focus on small square bells, weighing up to 60 pounds, with adaptability for rapid collection and unloading at ports. Design goals prioritize simplicity, safety, durability, and ease of maintenance. The above images show two separate concept designs of what we're trying to complete. For the image on the left-hand side, top left, this was our initial design. This was the 53-foot semi self-loading hay trailer initial concept. And on the right, we have our smaller scale. Uh, it uses a boat frame trailer, and we believed due to financial restrictions, it was more feasible for us to focus on the design that's on the right for a senior design project.
The constraints from this project can be broken into two different types of categories, qualitative and technical constraints. Qualitative constraints are those that relate to the project and getting it to the end result as on time. Those consist of the budget, primarily the material costs, with that really skyrocketing and bringing up our total costs overall. Limited time frame, as the scope and the project started to grow, really we had our timeline started stretching out. Team coordination, so really making sure that everyone was on the same page and we all knew what we wanted to do was the exact same thing across all four of us. Uh, the demonstration quality, so really we want to make sure that what we demonstrate at the end of our project is what we promised on at the very beginning. And finally, local support. So rather, we wanted to make sure that we could gather our local support and build some relationships to support this endeavor. But it's rather difficult since there's no actual implement manufacturers per se. Most of them are just sellers and retailers. And um, sellers. The technical constraints consisted of things such as the trailer weight, optimizing the use of the materials so that we could lower the cost of materials while still keeping the same factor of safety and rigidity. Um, we were limited in our manufacturing ability since we don't really have a huge big shop with a bunch of expansive equipment. Compliance and standards, since this is supposed to be a road going trailer, making sure that it's legal with the Federal Highway Administration and DOT. And technically, the scope of the project, since similarly as the budget started to grow, the components of the project and what we want to include started to grow. So that was something that we had to kind of contain and wind down a little bit. In order for us to be successful for this project, we need to incorporate and utilize the engineering skills that we've learned throughout our education. Some of these skills include statics and structural analysis. These include evaluating the forces and the stresses or moments on the actual system in the frame, um, using Hound calculations and ensuring that there was structural integrity. Material science, so kind of balancing the cost of or balancing cost and weight and not going too overkill with the material, but just enough so that it was still safe and light. Machine design, so this is where we got more of the calculations for specific tools or specific machines, such as like rollers or gears. So this is where we were able to determine if it was going to be fitting for our situation, and also validate it with our calculations that it would be suitable for our project. Same thing goes with safety factor and failure analysis. These were skills that were learned throughout our education, primarily in machine design. And this is where we use to make sure that the system as a whole would operate and would perform as due without injuring any of the operators or without failing unexpectedly. We also used failure analysis to look at where things were failing and why, so we can anticipate future failures with reiterized design.
Hi, I'm Cole Tinsley, and I'll be discussing some of the risk factors that were involved in our design and project process. Some of the initial issues that we ran into were designs that were too large, complex, and costly for us to actualize over the course of this year. So, as a result, we ended up with some time delays regarding our schedule that we set for ourselves. The way that we decided to fix this problem was by coming together and nailing down one definitive design, which ended up being the one in the bottom right-hand side of your screen there. That's the 3D render that one of the 3D renders that Ethan Myers produced for us. Some of the cost problems were still present though. This design, although cheaper than our initial design prospects, still requires additional funding. So we ended up setting up funding brochures, which I think just finished printing, so that we can reach out to local suppliers for more funding. The scope and scale of our initial design was for a commercial project, that is to say, something that would be used actually in farming to go from field to the highway, both for picking and transportation, which is not the scope of our current design, which is more about the picking process and moving it with the rollers in the back. Some of the considerations that we had to make regarding risk didn't involve the success of our project, but rather the actual safety of the project itself. And for that, we had to consider both road security, that is to say, transporting it from place to place, as well as the safety measures that we would need to implement during the function of the machine, that is to say, one is picking bales in the fields. For future considerations, things regarding that larger industrial design, we would need to, of course, consider much stricter codes, as well as ensuring that we have warning labels to reduce the liability concerns that would be involved in the project. In the bottom right-hand corner, we see the render of the travel configuration, that is to say, how it would be packed when we're moving our project from place to place.
Moving on to our project timeline. This was the initial timeline that we proposed for our project, and it started to grow fairly quick. the scope of the project started to grow fairly fast, started to add details and components that just drew the timeline out, added cost, added weight, manufacturing time. Because of this, we had to reevaluate our timeline through as we were going through on this term. So this is the preliminary and the early uh, initially proposed timeline. We can see that by now, early December, we would have already had our most of our components built and or at least underway being built, and we would have been started testing um, in the beginning of February. We can see though, this is not the case. So this is a project timeline, and this is actually what happened. Really what happened is that we generated the concepts, and we really started with that in August, September. So that was on task. And same with our CAD modeling. We modeled our CAD designs and we finalized those through October. So that was all on task. Our material estimate, though, started to get pushed behind because while we were modeling on time, we didn't necessarily finalize the design until a little bit later. So because of that, it wasn't until November that we were able to get to our estimates, our materials. Similarly, that did push back our fundraising. So because of this, we are currently still seeking our fundraising out right now. We have brochures made, and we have been going to local businesses and trying to procure local funding. At the end of this month, though, before the end of the term, we'll like to have funding secured, at least some portion of it, so that we can start ordering materials and start building. For the following term in spring, plan to have the trailer built, or at least the primary components of it built by February. Following month in March, we plan to have the first round of tests. We plan to assess that test and evaluate our design in the following month in March. And then in April, we hope to kind of refine that, put the final touches on it. And then in May, we expect to have a demonstration ready to show everyone. Finally, some considerations for the second part of senior design. Firstly, we really want to make sure that the scope of this project stays contained and really doesn't grow unexpectedly. We kind of experienced that in the first part of this term, and we want to make sure we don't have that happen again. Secondly, we want to make sure that the timeline is on point. We want to make sure that we are not missing any deadlines, kind of like how we started to push back our CAD design a little bit, and it started to get a little bit behind schedule, and because of that, we had to put other things behind schedule. So we really need to make sure that give an acceptable amount of time for things to get off task, or for things to get delayed if need be, and that we still have room to recover if possible. Additionally, we need to be realistic with our funding. So if we are not sure that we're going to be able to get what we expect to have, $2,000 for our trailer, then we need to reevaluate our design. And finally, we want to try to make sure that we leverage our existing skills. So myself, as the team manager, I have skills with welding and fabrication. Scotto has a lot of fabrication experience as well, working on the farm. So combined, we want to try to use these skills to limit the costs and any upcoming expenses that could occur with the fabrication building of this trailer.
Okay, for the budget. Our first trailer, which we designed for a full-size semi-truck, 53-foot trailer to come off the federal highway, state highway, right onto a farm, no issue. That pictured in the image was to be a roughly $100,000 to $200,000 machine. A few $100,000, maybe in production a little bit less, but with certification, it gets pretty spendy. Small scale, large budget, all the functionality, just on a boat trailer, about $10,000. And then small scale, small budget, that ended up being about $2,000 with room for pushing that cost down.
That's the end of our presentation. Thank you guys for watching.